Hey guys, all right, so we're going to be doing 6-8 today, which is graphing radical functions. Just as a reminder, what you should do is watch this video of this class, and I want you to take notes, and I will tomorrow in class take a look and make sure that you actually took some notes on this. Also, make sure you check Schoology for the homework that's assigned for tonight. All right, so this is just kind of, this first screen is just kind of a general way to look at the graphs of radical functions. This is the parent function. I want to kind of revisit that in a minute. First, I want to kind of remind you about domain and range, okay? So domain is the thing that you can actually, what can you plug into the function? And of course, because there's a radical involved for this particular one, f of x is equal to the square root of x plus 5, there is a radical involved, so there is going to be some sort of restriction. The easiest way, I think, to find the domain for a radical function is to take the radicand out, whatever's under the radical, so in this case it's x plus 5, and say that that thing under the radical has to be 0 or greater. So in other words, take it and set it greater than or equal to 0, and then solve. So when I solve this, I'm going to subtract 5, and I would get that my domain is that x is greater than or equal to -5. And that makes sense, right? Because if you plugged in something like -6, you would end up getting the square root of -1, which would not be a real number. So there's your domain. If I was talking about the range of a radical function, or any function, I want to see what my answer can possibly be. So think about it. If I asked you to take the square root of something, and I said, what can my answer possibly be? My answer has to be a number that's either 0 or greater. I can't get the square root of a number coming out to be negative. So my range in this case is that y is greater than or equal to 0. Okay, moving on. You try that, so pause the screen for a second and then try this problem and then come back and play and we'll see how you did. Okay, so if I was looking at the domain of this, well again, I'm going to take out that radicand, which in this case is x plus 6, and I'm going to set it greater than or equal to 0 and then solve for x. So I get x is greater than or equal to -6. So that's my domain. All right, range is a little trickier in this case. If I look at the range, well, this right here is going to have the highest thing I can get an answer for that would be 0. So in other words, if I put -6 in there, I would get the square root of 0, which is 0, and then 2. So think about it. My lowest answer I could possibly get is 0 plus 2, or 2. So my y, or my range, is going to be greater than or equal to 2. Okay? All right, moving on. Let's do this together. We're going to graph the parent function for a radical, because this is really what this section is all about. So think about it. When I plug in a number for x, well, what can I plug in? What's the lowest number I can plug in for x? So I'm thinking about my domain. My lowest number I could plug into for x is 0. I can't plug in a negative number. When I plug in 0, I get the square root of 0. Square root of 0, which comes out to be 0. So plot that point, 0, 0. Next number to plug in, how about 1? What's the square root of 1? It's 1. So plot the point 1, 1. All right, what's the next number I should plug in for x? Well, some of you might say 2, but then I have to figure out what the square root of 2 is, and it's going to be some decimal. So I would rather plug in a perfect square. So I'm going to plug in 4. What is the square root of 4? It's 2, so now plot that point, the point 4, comma 2. All right, and then the next one maybe would be 9, so that the square root of 9 is 3. So plot that point, 5, 6, 7, 8, 9, then up 3. And this is what the parent function looks like, okay? I need you to be responsible for that for at least, say, these 3 points. Okay, so I want you to know the point 0, 0, 1, 1, and 4, 2. Okay, that's the parent function. All right, next, we're going to start talking about transformations. If you remember, when I had the parent function y equals x squared, that was a parabola. What did this plus 1 do outside of the parenthesis? That made the graph shift up 1. But then if you remember for this parabola, when I had a plus 1 inside of the parenthesis, What did that do to the graph? Well, that shifted the graph. That was a horizontal shift. It shifted the graph 1 to the left. Okay? If that was x minus 1 in the parentheses squared, I would have shifted 1 to the right. Okay? What does this minus sign do? Well, if you remember, it turns the parabola upside down. And then lastly, if I put a constant in front of the x squared, what does that do to the parabola? Well, if you remember, you would multiply all the y coordinates by 2. Okay, so this is just a quick little summary to remember what we did with transformations. All right, so all of these types of transformations are going to apply to a radical graph. So for a radical graph, what do you think that plus 1 is going to do when it's outside of the radical? It's going to shift your graph up 1. If that plus 1 is under the graph, it's going to shift the graph left 1. Okay, and again, if it was the square root of x minus 1, it would shift it right 1. What do you think that that's going to do? It's going to reflect it over the x-axis. In other words, it's going to make that graph go upside down. And what about this 2? That 2, you're going to multiply all the y coordinates by 2. Okay? So, to sum all that up, this is what you're going to do. Okay? This A is your number that you're going to multiply your y coordinates by. That h is going to be your horizontal shift. So this is multiply y coordinates, the A. The h, in other words, the number underneath the radical, that's your horizontal shift. And the k, the number outside of the radical, is your vertical shift. Okay? This is more details of it. There's actually a pretty cool animation in your textbook if you wanted to look at it on page 987. All right, so let's get down to it, and we're going to do this one, okay? And then we're going to try to state the domain and the range. And that, to be honest, stating the domain and range is way easier by looking at the graph, okay? So check it out. Let's do this before we do anything else. In black, let's do the parent function. If you remember, the parent function is 0, 0, 1, 1, and 4, 2. Don't even need to connect it, just kind of use those dots as a reference point. Now from there, in red, or let's do it in blue, we are going to talk about the shifts. Well, that is going to be a shift 2 to the right because it's minus. And this is going to be a vertical shift of 5 up. So I'm going to take each one of these points and I'm going to shift them 2 to the right. So I'm going to start with the 0, 0, shift 2 to the right, and 1, 2, 3, 4, 5 up. Then I'm going to take the point 1, 1 and shift 2 to the right, and 1, 2, 3, 4, 5 up. And then the last point, the point 4, 2, 2 to the right, and 1, 2, 3, 4, 5 up, okay? So this is what I end up coming up with, the blue graph, okay? All right, let's talk about the domain. Okay, I could think of the domain algebraically as taking that x minus 2 out of the radical and setting it greater than or equal to 0, and I would get x is greater than or equal to 2. Now, look at the graph. If I look at the graph, notice that I start here at 2, and it's everything to the right. So again, my domain is x is greater than or equal to 2. All right, let's look at the range. Well, the range, my answer is going to be 0 plus 5. That's the lowest answer I could possibly get. And look at the graph. The graph starts at 5. That's the highest point right there at 5, and it goes only up. So my y is going to be greater than or equal to 5. So that's my range. Okay, pause the graph for a second, and pause the video for a second and try this problem, and then come back and see how you did. Okay, looking at this one, we have a few things going on. Well, first of all, let's do this. Let's, in black, plot those points for the parent function. Sorry, in black. Okay, so 0, 0, 1, 1, and 4, 2. And then from there, I want to, before I do anything else, the order does matter. I want to multiply my y coordinates by -2. So check it out. This first graph right here, this first point right here is 0, 0. When I multiply that 0 times -2, I still get the point 0, 0. Okay? Next point is 1, 1. When I multiply this 1 times -2, I now have a new point of 1, -2. So this is my new point, 1, -2. All right, and then my third point, which right here is the point 4, 2, if I multiply that y-coordinate times -2, I would have a new point of 4, -2. I'm sorry, 4, -4. So I'd have 1, 2, 3, 4, and then down 1, 2, 3, 4. So that's my point, 4, -4. Okay, so two things happen with that. It's a flip over the x-axis, and that's why it's a negative number, and it's also kind of a stretch. Notice that it's a little bit of a steeper curve. All right, but we're not done yet, because now I've got to do the horizontal and the vertical shift, so I'll do those in blue. This 3 right here would be 3 to the left, because it's under the radical, and it's a plus, and this -1 would be 1 down. So let's take each one of those red points and shift them 3 to the left and 1 down. So I'm going to take the first one, 0, 0, and I'm going to shift 1, 2, 3 to the left and 1 down. The next point, red point, 1, -2, I'm going to shift 1, 2, 3 left and 1 down. And then the next point, the 4, -4 point, I'm going to shift 1, 2, 3 left and 1 down. And this right here is my graph. Okay, stating the domain. If I look at this, the domain starts at -3. Here's a -3 right here, and it's everything to the right. So x is greater than or equal to -3. And again, if I took my radicand out, x plus 3, and set it greater than or equal to 0, I would get the same thing. X is greater than or equal to -3. My y, my range, well, if I look at this, I'm at -1 and everything lower. So y is less than or equal to -1. Okay, so that's my range. Okay, this right here is just another example of how each thing is done. They show it in steps, step 1, step 2, and step 3. You can maybe try that one on your own. This don't worry about, and then I wanted to, you don't need to worry about that either. I want to talk quickly about a cube root function, okay? A cube root function, if I looked at the parent function and I did an XY chart for y equals the cube root of x, okay? Well, I could plug in -8 if I wanted to. What's the cube root of -8? It's -2. So if I plotted that point, it would be -8, -2, which would be over here. This is the block graph right here, okay? This is it right here. Here's the parent function, okay? And so on. I could plug in -1. The cube root of -1 is -1. So that's this point right here, -1, -1, okay? 0, the cube root of 0 is 0 right here. Cube root of 1 is 1. That's this point right here. And then the cube root of 8, okay, is equal to 2. All right, that's this point right here. All right, so I just want to make it a point that you could do all of that same shifting and also multiplying the y-coordinates using all those transformations, okay? All right, last example. If I wanted to rewrite this, okay, first of all, if I asked you to graph this graph right here, y equals the square root of 9x plus 18, it looks impossible to graph. However, think about this. Is there anything I can factor out of this? 9x plus 18. And there is. I can factor out a 9 to get x plus 2. And then I can use my properties of radicals, and I could say that equals y, that's y equals the square root of 9 times the square root of x plus 2. But what is the square root of 9? It's 3. So now it's nice and easy to graph. All right, I'm going to graph this. Y equals 3 times the square root of x plus 2. Okay, the first thing I'm going to do is plot the points for my parent function. Then I'm going to look at this and say, well, what do I have to do to my y-coordinates? I multiply each y-coordinate by 3. So this will now still be the point 0, 0. This will now be the point 1, 3. And this will be the point 4, 6. 3, 4, 5, 6, okay? And then from the last step here is going to be, I'm going to shift everything 2 to the right. Oh, sorry, 2 to the left, because it's a plus. Okay, so take each one of those points, those blue points, and shift 2 to the left. This point 2 to the left, and this point 2 to the left. And that should be my graph. Okay, hopefully all of that worked out. This is going to just tell you all of the things here, and it tells you the translation, the transformations. Hope you took good notes.